Okay, so we're in section 2 of chapter 12. We're going to go back to graphing rational functions again. We started that in the first section. Then we wrote some equations. And now we're going to be a little more sophisticated with transforming the rational equation. So the parent rational function, what would be the most basic number that you could put in for the constant? In the end, Cameron, what is it?
1.
1. So there it is, the parent rational function. So when we graph the parent function, we already have created the domain and range and done this a couple of times. You've already compared this to a few different functions. What is the one value not allowed in the domain? In this, 0. In this domain, 0. So we say the domain is all non-zero numbers. Sometimes people write that as all real numbers except 0. And then the range, can anyone identify that one? What y value never happens? It's 0 as well. So this is just the most basic function. Okay? We learned that these dash lines could be put between these branches, these hyperbola, right? And what do we call those axes that you place between them? The asymptotes. Good. And for the parent function, they're always on the x and y axis. And for many of the early functions that we've done, these asymptotes keep falling on those because we've only done some basic functions. Today we're going to actually see the asymptotes start to shift around a little bit. So keep drawing them in. Okay, so we're going to graph y equals 4 over x and compare it to the parent function. Y equals 1 over x. So we might start by graphing the parent function, which we might not even need to use a table to graph. We kind of know where it is. If we plug into the parent function x value of 1, we get out 1. X value of 2, we get out 1/2. X value of 4, we get out 1/4. Even if I go clear over to 10, an x value of 10, I get 1/10, right? So I'm approaching 0 but not crossing it. If I plug in 1/2, 1 over 1/2 kicks the 2 up to the top, right? 1 divided by 1/2 is 1 times 2 over 1. So the denominator kicks up to the top and we have 2. 1 divided by 1/4 is just 4. And if what would I divide 1 by to get a y value of 10? 1/10, right? So, you know, it's approaching that axis but never crossing it. It should look like a C shape with arrows on both ends, right? And then if we plug in the opposites, the opposite domain, -1, we get -1 and so on. So that's our parent. That's what we're comparing to. And now let's identify the domain for this function. So what value may not be put into the domain? Good. So we could say all non-zero numbers again. When I use that pound sign, it means numbers. Okay, and then we'll find the range in a minute. So we can use 0 as the dividing line between the two sets, the two domains that we have here, for the two branches, huh? So give me the values we would use, or we could use. You want to use 4? So 4 might be down here. -4? And good, it's nice to have at least 2 fractions. Yeah. Because they have such a different effect on things, right? So let's start with, shall we start, since 4 is positive, let's start with the positive domain. If we plug 1/4 in here, what do we get? Bring it up. 4 times 4 is 16. Good. If we plug 1/2 in, what do we get? 8. If we plug 1 in, it just becomes a normal kind of fraction, huh? When we plug in 2, we get 2. Good. Plug in 4, we get 1, and so on. So because that's all that's going on in this function, we can just take the opposites. If we plug in -4, we get -1. So the opposite of what we found with +4. So these are all opposites. You can test it if you don't understand that, right? And then we graph. I'm going to pause the video while I graph. You do that. Okay, so we have a slightly different look to this function as compared to the parent. So then the question is this a vertical stretch or a shrink? So if we imagine grabbing the ends of that parent function, would we be pulling it or would we be letting it relax to get this red one? We would be stretching it, right? Stretching it. So this is a vertical stretch. And what is the math behind that? Look at the equation. The math is, the 1 is a 4. The 1 has increased. The numerator has increased, been multiplied by 4. And that causes a stretch, okay? So look for that. If you have a value greater than 1, you probably have a stretch, depending on what's going on in the denominator. Okay? Is there any other translation or any other kind of transformation? Is there a reflection? Sliding things up or down? No. So because there's not, we can say that the one value that y will never reach is 0 again. So all non-zero numbers for the range. And is that all we need to say? I think so. Okay, so the one thing that we want to include is that imaginary line that this new graph won't ever cross. And so they are called the asymptote. And they're linear, so when we write them, we write, in this case, y equals 0, and in this case, x equals 0. Now we're going to see them shift around a little bit today, so I really want you to draw them in. When you do, notice that the new hyperbola never crosses it. And if I end up seeing on a quiz or a test, somebody draw this in and it crosses like that, then it's wrong. You really need to have that dividing line. Okay, I want to say that each time. So, okay, go ahead and graph this and see what you can come up with. I'm going to pause the video. You're going to come back and see what we came up with here. Okay, so what value are we approaching in the range but never touching? What y value do we never touch? 0 again. Same thing we've seen. All non-zero. And then as far as the transformations, we see the parent function is in black and this function is in blue. So they're totally in different quadrants. What do we call that? That's a reflection. Good. And has there been any other kind of transformation? Vertical stretch or shrink? Shrink. Good, it's a shrink. Notice that this point in the curve, the C shape, is closer to the point of origin than the parent function. So it's a vertical shrink. It's as though you took the parent function and you relaxed it. You took the ends like they were made of rubber band or something and you relaxed it and it shrank back toward the point of origin. Okay? So vertical shrink. And has it shifted up or down? Or left or right? No. So the asymptotes are still where we have found them before. Okay? So the asymptotes are at x equals 0 and y equals 0 still. We're about to see a change in that. At least, now this is something a little different. We're going to subtract 1. Notice that in the model they say y equals 1 over x, there's the parent, plus k. What happens when we plus k to the parent? What do you think it's going to be? What do you think? Translation. Translation what way do you think? And Ellie, you're saying down because -1? Or Kate is saying to the left. So let's see, is it down 1 or is it to the left? Who thinks it's down? Who thinks it's to the left? More people are thinking to the left. Okay. But Ellie thinks down. Tom is agreeing with her, by the way. Okay, what value may we not input? 0. Okay, we're going to use the same domain. I'm going to pause the video, put your domain, and graph it. And because I want it a little bit more. So let's plug in 1/4. 1 over 1/4 gives us 4. 4 minus 1 is 3. Good. How about if we plug in 1/2? 1 over 1/2 gives us 2. And then 2 minus 1 is 1. When we plug in 1, we just have what? 1 minus 1 is?
0.
0. Ooh, a 0 shows up in the y value. That's new. Okay. And we plug in 2 and we have 1/2 minus 1, which is negative 1/2. Plug in 3, 1/3 minus 1. What is 1/3 minus 1?
2. No, wait, negative 2.
1/3 minus 1. There's your 1 that you need to use, right? And so it's negative 2/3. Negative 2/3. Now, let's see. Would this other domain give us just the opposites? Let's be careful. Plugging in negative 1/4. 1 over negative 1/4 gives you what?
4.
Negative 4. And now when we subtract 1, negative 4 minus 1 is?
Negative 5.
Negative 5. It is not the opposite of 3 here, we found earlier. Okay, so you can't just take them and make them all opposite here. How about negative 1/2? 1 over negative 1/2 is? Negative 2 minus what? Is negative 3. Okay, this one's a little easier. 1 over negative 1 is negative 1 minus 1? Negative 2. 1 over negative 2 is just 1 over negative. We could say negative half, right? Negative half minus 1?
Negative 1.
1 is this, right? So negative what?
3 over 2. Negative 1.
Or you could leave it as 1, negative 1.5, right? How about negative 3? 1 over negative 3 minus 1? Isn't that just negative what? Negative 1 1/3. Okay, I'm going to pause to graph. Okay, so we see that the function has dropped down, as Ellie said. We could draw an asymptote here. And so how do we write that asymptote? Y equals negative 1. I don't know if you said it already. But so this appears to be the horizontal asymptote, right? So it shifts things up or down. X is still equal to 0. This one has not changed. Still there. Okay? But what other let's do domain and range.
Yeah.
Domain, what's the value that may not be input?
0.
X may not equal 0. And the range, Y is never going to equal 0 either. Or you could say all non-zero numbers for those. Say it again?
Y equals 0.
Oh, I'm sorry, that's a mistake. Thank you.
It's great.
Am I videoing?
Negative 1 and 100.
Do you see the menu for the video, anybody? What happened to it? What value does the range not equal? What does Y not equal?
Negative 1.
Y will never equal negative 1 this time. All numbers but negative 1. Right. And then what about the transformation? How do we describe this? Translation. Good. Translation down 1. 1 or negative 1. Vertical translation negative 1. Okay? So if you want to move your function up or down, you add something to it. You add a positive or a negative. A positive will raise it up, a negative will raise it down or lower it. So what do you think this is going to do? What X value may not be input here?
You have to graph it.
Negative 5.
X may, good, not equal negative 5. Look at that. X may not equal negative 5. So I could go in right now and say 1, 2, 3, 4, 5. There's going to be no X ever hitting here. Oh, it's an asymptote.
That's a graph.
Yes. X equals negative 5 is an asymptote. Okay, and then go ahead and pause and come back and look. Looking back here, this range should say Y may not equal negative 1. And then the asymptote is Y is at negative 1. Those are two different things. Okay, so go ahead and pause and come. Okay, so we found the domain has shifted. So the translation is left 5, which is related to that value in the denominator, right? And we have the asymptotes. Make sure you have those, okay?
Oh, this is only day 1. I kind of used